طيب بسم الله الرحمن الرحيم. So last time we started to talk about key distribution using symmetric encryption, right? So we talked about Kerberos. Kerberos uses purely symmetric encryption. So it's used to distribute symmetric keys in distributed systems. And for that, they use user authentication, which leads to exchanging some tickets, which allows a user to access devices or services in a distributed system for a specific lifetime. Today, our topic is to talk about key distribution, but using a asymmetric encryption. So for asymmetric encryption, we have public key, you don't have private key, right? And as we said, public keys are public, so I can simply send you my public key. But what is the problem here? The main problem is that, if we have, again, the famous example of Alice and Bob, so Muhammad or Nawaf can send to Alice, say, I'm Bob, can send to Bob, say, I'm Alice, right? And this is my public key, okay? And later on, eavesdrop on the channel and be able to decrypt everything. So it's possible, which is the main issue that we discussed in Diffie-Hellman. Diffie-Hellman, again, is used for key exchange, but again, it does not avoid or mitigate the man-in-the-middle attack. So this is the main problem here, that exchanging key distribution needs to have also some kind of authentication. I need to authenticate the person who is sending me the public key, right? So this is in a nutshell the issue that we are going to discuss today. So one major role of this public key encryption is to address the problem of key distribution. So we know that key distribution can be done using public encryption. Because why? Because once you have the public key for me, you can always use it to encrypt the symmetric key, right? So we can distribute keys very easily using public cryptography. But again, the problem remains that I need to make sure when you give me your public key that you are really the person who say you are. So there are two distinct aspects to use of public key encryption in this regard: the distribution of the public keys and the use of the public keys to distribute symmetric keys or secret keys. Okay? So therefore, we have the concept of public key certificate. Okay, so a certificate is nothing but a text file, okay, in which you put your public key and you send it. But the problem here is that we need to make sure that this certificate is somewhat authenticated or authorized. So public key certificate consists of a public key plus a user ID. So you need to identify yourself of the key owner with the whole block signed by a trusted third party. So the only way that we can authenticate this certificate or this public key is that it has to be signed by a specific authority. Okay? So when you send me your public key, I don't trust that you are the person who owns this public key, right? But when the key comes through a certificate authority, I have more confidence now to trust that certificate. I told you, why do I have to trust the certificate authority? Similar to the fact that you trust the bank. Similar to the fact that you trust the government. So you just have to trust someone. Okay? But it's much better than trusting a normal person. So this third party is, as we said, we called it before key distribution center. Okay? It's or we called it for the case of Kerberos, we called it a authentication server. So you have to have a centralized entity that you kind of trust, okay? So through which, if you receive the public key for Alice and for Bob, you really trust that it's for Alice and for Bob. But how to do this? How do we do this? Okay? Typically, the third party is a certificate authority. So here, and instead of the terminology that we use for the case of Kerberos, which is authentication server, here we call it a certificate authority, okay? That is trusted by the user community. It is trusted, okay? So it's a fact. You have to trust it. You don't have any other choice. such as a government agency or a financial. So, and actually, certificate authority now is built as a service in, like for example, Windows Server. Okay, so Microsoft has a certificate authority, and they integrate this in their operating systems. Again, so you have to trust, you don't have any other options. You have to trust Microsoft. You have to trust, similar to the fact that you trust Facebook, you trust these entities. So it's just that you have to trust someone. So a user can present his or her public key to this authority. So if you want to claim that this is your public key, don't talk to me. Talk to the certificate authority. The certificate authority is going to verify your identity, and then based on that, they will sign that this is indeed the public key of Alice or for Bob, and only then everybody else can trust it. They don't trust you, but they trust the certificate authority. The user can then publish that certificate. So once the certificate is signed by the certificate authority, then you can store it anywhere. Okay? It's plain text. At the end of the day, it's plain text. Okay? So you can store it, you can exchange it, you can do whatever. So anyone needing this user's public key can now obtain that certificate and verify that this is valid through, we don't verify the identity of the person, we identify the identity of the certificate authority. Okay, so we have to authenticate the certificate authority in order to trust that this is a public key for Alice or this is a public key for Bob. Okay, we don't authenticate Alice or Bob because at the end of the day, we don't even trust them, but we trust the certificate authority. Once we trust the certificate authority, we can accept the public key that is coming from them. So we'll see now how it's done. So we do this through attached trusted signature, similar to the message authentication codes. So remember the message authentication codes? Remember? Yeah, you will have to remember on Thursday. The message authentication codes is a way for us to make sure that the message is coming from a trusted person or a trusted authority, right? But remember, in order to do this, we need to have a key exchange. Here, we don't yet have a key exchange. We're trying to do this for key distribution. Okay? That's why we have to do this certificate. The certificate, it's a way for us to use in order to exchange any information or a key or a secret key. So this is the model. This is the security model that describes this. So I know Bob, but I cannot really verify that the public key that is coming is really coming from Bob. So in order to ensure this, I have Bob's information, and I have the public key, and all of this is public information, right? But again, I cannot authenticate or verify this public key. So the way for me to do this is that I trust the certificate authority. So what happens is that the information for Bob, the information for the public key, and the information for the certificate authority will all be hashed. Okay? And then after hashing, I will have to encrypt this using remember, using a.
Again, what is the question?
The question is, I did the hashing for this whole thing, and then I know that I have to encrypt this in order to authenticate the certificate authority. Okay? So this needs to be encrypted using what? The private key of the certificate authority. Bravo, Ali. As we said, for message authentication, we use the private key. Huh? For encryption, we use the public key. Okay, then I can generate the signature as a function of the hash code using certificate authority's private key. Everybody knows the public key for the certificate authority, so I can use the public key for the certificate authority to decrypt this and then later on to compare the hash that I generate at my end with the hash that is coming after decrypting this message authentication code using the certificate authority's public key. ماشي? So this side, all this side, is where at the certificate authority. Okay, so the certificate authority will generate this hash, and then, will generate this hash, and then will decrypt everything using the certificate authority's private key. Then, خلاص, once they do this, it becomes like a file. Anyone can store it. Okay? If I want to receive the public key for Bob, then the way to do this is to use the public key for the certificate authority, not for Bob. Okay? I use the public key for the certificate authority to decrypt the hash. And then, طبعا, we know that the hash is one way. Okay? So we have to perform the hash for the message itself. And then we compare both. Okay? If the two hashes are identical, then this file is authentic. Then and only then I can take the public key for Bob and use it for anything.
So I will have two copies of the message, one hashed and one without hash?
We always do this. We have the message with an encrypted hash. So we do two steps. We decrypt the hash, and then we have to generate the hash locally, and then we compare, because the hash is one way. Hash is always one way. Always.
The hashed copy will be only to authenticate?
Yes, only to authenticate that this message is coming from a trusted source. From a trusted source. And now we trust the certificate authority. We don't trust Bob yet. Okay? So we trust Bob through the certificate authority. Okay? And the notation to do this is that we use the certificate authority, okay, to authenticate the public key for Bob. This is the notation. We'll talk about this. ماشي كده؟ So the security model for the city. So now the ITU. So we talked about three different organizations for standards. We talked about NIST, we talked about the ISOC or IETF, and we talked about ITUT. So ITUT, they generated a series of standards. They call them a X500. The X500 series, they call them series. Part of it is what we call a X509. And in this X509, they provide the recommendation for what you call directory services. Okay? So, the X500, in total, in all, they provide the directory services standards. So as part of this, they provide the X509, which provides the certificate standard. They define by the format of the certificate what are the content of the certificate exactly, and what each field is used for. It's a protocol. It's a full protocol. ماشي? طيب, the directory may serve as a repository. So the X500 series, they define the specifications for the directory services in total. Part of it is certificates. Part of it is what we call LDAP. I'm not sure if you're aware of LDAP. LDAP is like a unified server which is used for user authentication in a distributed system, similar to the authentication server, But this is the way for you that you authenticate yourself to be able to access any other server. So if you want to use blockchain, if you want to use Blackboard, if you want to use MyQU, if you want to use email, you have to authenticate yourself to one server, which they call it LDAP. So this is also which adapts the Kerberos concepts exactly as part of this LDAP implementation. Type this the standard for X509, they provide by the certificate repository. Certificate repository is a repository in which you store all the certificates for all the public keys, okay, of everyone in the entire organization. Okay, and every node uses these certificates to again verify the certificates for other entities in the organization to be able to communicate with them. Of course, everything is done using caches in the operating system. So in your laptop, you store list of all the verified public keys of all the entities you can communicate with. But of course, there is an issue here because at some point, this person might go out, this person might come in, a person مثلا graduates and you have to go away from QU. So we need to imagine the fact that these public keys or these certificates, they have a lifetime as well. ماشي? So this is also defined as part of the standard. So this authentication protocol based on the use of public key certificates, it was initially issued in 1988. You don't have to really know much about the history, except that we started with version 1, version 2, all the way to version 7. So now version 7 has been released in 2012, and I think there is version 8 even and version 9 now. So based on the use of public key cryptography and digital signatures for the message authentication for the certificate authority. The standard does not dictate the use of any specific algorithm for public cryptography. However, RSA is recommended. We talked about other alternatives to RSA, like what? حد فاكر? For public cryptography. RC4 is stream cipher for symmetric encryption. Like الجمل, like elliptic curve. Okay. Diffie-Hellman is also used. However, Diffie-Hellman, as we said, is used only for key distribution. It's not used for encryption and decryption. But RSA is recommended. ماشي? But it's not dictated. So this is the format of the certificate. As you can see, we started with version 1, which contains this information, but later on we had to add this, and later on we had to add this. Okay, so these are extensions that came with version 2 and version 3 and so on. ماشي? So the format is, it looks a little bit complicated, but it's easy. We have, of course, the version, which refers to version 1, 2, 3, 7, whatever. And we have the certificate serial number. So the certificate itself has a serial number. Okay? We have to identify this. It's a file at the end of the day, and we have to put like an identifier for that file. This part in the standard is redundant. You don't have to worry so much about it. But this is the issuer name, the name of the certificate authority. In our case, could be QU, it could be like Microsoft, someone that you trust. So this is the issuer name, the certificate authority name. And as we have discussed, we have to put not before and not after. So there is this certificate is not valid before that time, and it's not valid after that time. Okay? So it's a file, but before a specific time, it's not valid. So why? Because at some point, as we said, a person is coming into the organization, okay? So he's identifiable within the organization, but at specific time. And another person may leave the organization, okay? So after that time, he's not identifiable to that organization, okay? So when he comes in, he may actually get some public key to facilitate the communication, right? And when he leaves, he should stop using that. Yes, so start and stop kind of thing. But even if the person doesn't leave, in many cases, the certificate also has some expiry time. You always have to renew that certificate. Again, because, like secret keys also, public keys, they can be also guessed using some, I guess, not the public key, I guess the private key. I guess the private key using cryptanalysis or anything. So always certificates, they have some lifetime, similar to the secret keys. They have also some lifetime. طيب. The subject name بقى اللي هو ايه؟ The person himself. اللي هو Alice, Bob. ماشي؟ And this is بقى the information which is the key itself. This is the public key. This is the public key, which is text, plain text. Okay? But we have an algorithm and the parameters. Because we have possible algorithms, we can use any algorithm. Mainly it should be RSA, but it could be Diffie-Hellman. Okay? What are the parameters? Parameters why? These are, what are these parameters?
For the key, to generate the key parameters would be
Yes, so we discussed this, for example, for Diffie-Hellman. For Diffie-Hellman, as we said, we have alpha and q, and alpha should be the primitive root of q, and so on, right? And as we said, these alpha and q should be shared, and they are public, right? Okay? But for RSA, we cannot share, like, for example, P and Q. P and Q, remember there was two numbers, two prime numbers, P and Q. These cannot be shared. These have to be stored locally. So we cannot share them here. So these are not parameters. Parameters are the things that you can share with the key. Like for the clear case for this is Diffie-Hellman. Diffie-Hellman shares alpha and Q. Also maybe other algorithms that we did not discuss, like for example elliptic curve or Gamal or something, they may actually share some parameters. So the standard here defines this placeholder to share any parameters that might be needed as part of the algorithm. ماشي؟ طيب. What is the issuer unique identifier and the subject unique identifier? This is done as part of version 2 بقى. As part of version 2 they said, okay, so I might actually, as a person, I might have multiple public keys. What stops me from doing this? I might have multiple, and actually it's the same for the certificate authority. Why do we have to assume that the certificate authority, كلها, they have only one public key, private key pair? They may have multiple pairs, right? Okay? Similar, the person may have multiple public keys. He may actually use a specific public key, for example, to communicate with Google. He may have another public key to communicate with Apple. He may have another public key to communicate internally within QE, and so on, right? So the issuer unique identifier and the subject unique identifier, they define the private public key pair. So you know exactly which pair you should use or which public key you should use. So if you communicate with me a lot, ماشي, maybe we communicate through different services, multiple services. So you should be able to tell which public key you should use because I have multiple of them, right? Also the extension, they define other criteria other than the before time and after time, where this certificate is valid. So we said that before that time the certificate is not valid, and after that time the certificate is not valid, right? صحيح. Extension defines other criteria. Like for example, the certificate is valid to be used from a specific domain or a specific system or for a specific service. So this certificate, for example, is used for banking services. This certificate is used for, for example, for QU related services. So if you try to use a certificate that is done or created to communicate in a certain domain, if you try to use it for any other domain, it will not be valid. Okay? So all of these, the time before and time after, issuer identifier, the subject identifier, and the extensions, they all narrow down the usage of a specific public key for a specific use, based on restricted with time and restricted with the domain of services that you can use this certificate for. And again, this is part of version 3. Okay? So throughout the time, this started to be more and more complicated, which again, it violates the concept that it's in the brain of some people to say that key exchange using public cryptography has no overhead. No, it does. It does. It has some overhead probably. ماشي كده؟ طيب what is this بقى؟ Huh? The hash, yes. This is the hash 4, which is again which is generated by the certificate authority, okay? And it's signed, which means it's encrypted using the private key of the certificate authority. ماشي. Once it's encrypted using the private key of the certificate authority, now we can store it as a file anywhere. خلاص. Because anyone can verify this using the public key of the certificate authority. Once we verify the public key of the certificate authority, we can accept the public key for Bob.
So it is hashed and
Encrypted, yes, hashed and encrypted. Similar to message authentication codes. Message authentication codes, we use it to authenticate a person, that the person who's sending this message is really the person who says he is, right? So in that case, we deal with the public key similarly. So we have to authenticate, but not Bob. We don't have to authenticate Bob. We authenticate the certificate authority. Once we authenticate the certificate authority, we accept the public key for Bob. ماشي كده؟ طيب. It's gonna get a little bit more complicated now. So obtaining a user's certificate. So user certificates generated by a certificate authority have these characteristics. So certificate authority's public key can verify the user public key, right? We said that. That was certified. ماشي. No party can modify the certificate other than the certificate authority, because the certificate authority is the entity that has the private key. Okay? So I cannot under any circumstances, I cannot change the certificate, okay, and make it still valid. The only one who can do this is the certificate authority. So certificates, therefore, are unforgeable. Therefore, they can't be stored anywhere without protection. خلاص, it's a text file. I can store it anywhere, which is good. Okay? If all users subscribe to the same certificate authority, there is no common trust of that. There is a common trust for that certificate authority. So, makes sense if we are all identifiable by the same certificate authority, right? So we can trust each other through that certificate authority. That makes sense. But do you imagine that we have only one certificate authority on the internet? Of course, it doesn't make sense, right? So we have many certificate authorities. Okay, so that will make the problem even more complicated now, because we have multiple certificate authorities. Okay, so we have to trust a certificate authority through another one, and this one should trust another one, and so on. So we have a chain of certificate authority, a chain of trust. Okay, so we have to have this chain of trust. There is no other way. The only way to avoid this is to have one certificate authority on the entire internet. We cannot do that. It cannot be done. It cannot be done. So currently it can be done with only exception in blockchain. Blockchain is a totally different story. So persons, they can trust each other without having any centralized authority. That's a totally different concept. That's why blockchain is very, very disruptive technology. It changed dramatically this concept completely. Okay, and that's why it's actually one of the technologies that's going to dominate the future by far. Yeah. And again, there are certain challenges that blockchain has really solved, which nobody paid attention to. Once it's solved, it opened the door for many, many, many applications. But in any case, this is not our scope here. We are used to the fact that we trust entity, we trust a centralized entity, right? And this concept is good for government because they have to be in control. And that's why some people, they perceive blockchain as a threat. It's going to take away the control from them and so on. Anyway, so if there is a large community of users, it may not be practical for all users to subscribe to the same certificate authority, as we said. Because it is the certificate authority that signs the certificate, each user must have a copy of the certificate authority's public key, which, as you can imagine, it's not valid for all the users on the internet that they have one public key for one certificate authority. So with many users, it may be more practical for there is to be a number of certificate authorities. So about a particular example. So we consider that scenario that we have a node A. We have a node A which trusts a certificate authority called X1. So we have a relationship here, okay? But we have a node B on the other side, which trusts another certificate authority, X2, right? So what happens if B wants to communicate with A, or in other words, B wants to establish a trust for A, or in other words, B wants to verify or use the public key for A. Okay? So how does this happen? So in that case, we should have a relationship between X1 and X2. Okay? So now, X2 and X1, they need to establish that trust. Since I trust X2, I can use the public key for X2 to verify the public key for X1. Once I have the public key for X1, which now I trust through what? Through X2. I can use the public key for X1 to verify the public key for A. So this is how we write it. We call this chain certificate. Okay, so this is a chain certificate. So this can get very, very long. ماشي? So we call, if we have two certificate authorities in the same level, we call this cross certificate. Because they are in the same level. هتقولي, do we have an alternative? We have other alternatives. Because there could be some hierarchy of a, it's like a tree. Okay? So this is how it looks like. So this is the scenario that we talked about. Okay? And now we trust. So this is how it looks like. On the internet, this is typical. This is typical. On the internet, this is how it should look like. So this kind of branching certificate authority, we call it a root certificate authority. Okay? It's a root. So it can perform, or it can facilitate the trust between different branches of the tree. Okay? In fact, in the book, in case you read it, in the book you say X can trust Z, and Z can trust X. So there should be a missing line here, which does not exist in the book. But it should be there. Okay? So this would complicate it even more, because this makes the tree a graph. Okay? So in general, it's a graph. ماشي? So as we said, we call this a cross certificate. Okay? So cross certificate happens if we have a peer-to-peer in the same level. Right? So X has a relationship with W. We call this reverse certificate. Okay? When X stores W to X, when it's stored here in X, we call this forward certificate. Okay? So this is what's explained here. So this is terminology بقى. We use cross certificates, reverse certificates, forward certificates. Okay? So in general, we have all these relationships. By the way, all of these certificates are stored in the directory server. Anyone can access them, and anyone can perform the verification for one certificate. Once you have verified the certificate, you store the public key in your cache. صح؟ هتقولي I have to do all this chain certificate. Every time I want to communicate, this will take a very, very long time. No, that's not what's happening. That's not what's happening. When you click on the browser in fact stores all these public keys in the cache. So you don't have to perform this every time. Perform it once and for all. ماشي? So as we said, if B wants to verify the public key for C, يعني it has to go all the way, right? So now it has to first trust V, okay? And for that it uses a reverse certificate, okay? And then from V it has to go all the way down to C.
But hasn't there already been established the ZX relationship?
Right, so that's, yeah, I was gonna say that. So it's another alternative is to say, B trusts Z already, okay? So I might as well use Z to trust X already, right? Once I do this, I can use X to trust C, okay? So if I have this relationship, how do I establish this relationship? The certificate will do that. So sometimes Z and X, they have this peer-to-peer relationship that X stores the public key for Z, or Z stores the public key for X. So this relationship exists. But sometimes this relationship does not exist. In which case, you have to use the reverse certificates to go all the way to V, and then from V, you have to use the forward certificates to go to C or to A.
Both of this makes sense because we're seeing it from this perspective, but how do they know that the other side has these certificates? And how does B know that A has access to X also? And
how does B know that A has access to C?
To X, and how does it know?
Hey, everything, yes, everything is stored on the directory server. Everything is stored on the directory server. These certificates are accessible by everyone. موجودة, okay? So if it finds that there is a certificate for the fact that Z has a public key, so Z, if Z stores the relationship or the certificate to allow it to verify the X's public key, خلاص, we'll go this way. If it doesn't, then we have to, and so on.
But first has to check A to see where it's coming from, right?
First it has to A?
And B has to check which certificates A has first, and then it goes to X to see what certificates
لا,
it has.
B will check which certificates it has access to on the directory server. Because B has access in the directory server through set of certificates, okay? Then it has to see whether it has the certificate for Z to X or not. If it has Z to X, then it goes to, and in fact, this is done iteratively. يعني it's not like every time you have to do all of this. No. I mean, B will try to check directly that it has access to X because it knows that X is verified. So if it has access to X, then على طول it performs this. If it doesn't, then it has to establish, it has to call مثلا this certificate authority, and this certificate authority has to call, and so on. Okay? So this is done iteratively. But the most important thing is that for us to be able to read this and perform these chain certificates and to know the fact that this is a reverse certificate versus this is a forward certificate and so on. And this is a root certificate authority. So these are the terminologies and the definitions that we need to be clear in our mind. ماشي كده? So this is the typical, of course it's getting more and more complicated, and that's why actually blockchain makes sense. يعني when you think about it, if I have this graph, I might as well have the يعني everybody is like peer-to-peer, and we don't have any certificate authorities, we don't have any centralized authorities.
No.
And yes, no root. There's no root. طيب, revocationless. Revocationless is a very important concept because we cannot imagine that certificates will be valid all the time. هتقول لي طب ما يعني we have the time limits. Yes, but during this time we have مثلا assigned a certificate to Nawaf, and this certificate is valid until maybe September. So Nawaf gave May وتخرج ومشي. Okay? So how come his certificate becomes valid after that time? Even that the certificate file itself says that it's valid until September, right? So we have to override this. So we have to override even the rules that's stored in the file at some point. So this is done through what we call a revocation list. So each certificate includes a period of validity, صح. But typically a new certificate is issued just before the expiration. So that's typically what happens. As we said, certificates cannot be, or in many cases they do not validate forever. Okay, at some point you have to renew it. Type. But it may be desirable for occasions to revoke a certificate because somebody has left, somebody has come in. So the user's private key is assumed to be, or the user's private key, not public key, private key has been compromised. So we knew that مثلا Muhammad has a security attack on his machine. خلاص يعني we cannot يعني blindfold ourselves from this event. So we have to act. Okay, so we have to isolate Muhammad from the entire network, and we have to revoke all his certificates. Okay, so there are certain occasions based on which I need to revoke, I need to override these certificates and make them invalid. So I do that through publicizing. So the certificate authority, any certificate authority in this chain or in this tree that we talked about, they provide almost every week, and sometimes even more frequent, they provide حاجة اسمها certificate revocation list, CRL. ماشي. So this certificate revocation list is also part of the X509 standards. The certificate authority has to send a list of all the revoked certificates. ماشي. And this this certificate revocation list is simpler, is much simpler. It contains the issuer name or the certificate authority, the list creation date, okay, and the next CRL creation. Why? This is the certificate authority says that the next revocation list is gonna be issued after 1 week. Why do we need to store this? Because if any server or any node wants to check whether this certificate is revoked or not, okay, they have to look at the certificate revocation list that they received from the certificate authority. صح? They go to this date and they see that this date is past. What does this indicate to you? This indicates to you that there is an update that you don't have. Okay, so you have to go and fetch it. Okay, so either the certificate authority, they publicize these CRLs, or in some cases you have to ask for it. You have to get the update. So that date is very important. So it indicates to you whether the list that you have is the most updated one or there is an updated one. So the list of entry, each revoked certificate entry includes a serial number. بس احنا عشان كده we have the serial number for the certificate. Remember we had the serial number for the certificate? So here, all we need to do is just to say that this certificate authority with this serial number is revoked. That's it. Okay? This is very simple. So سيبك من ده برضو قلنا ده redundant يعني. So also we have the signature. So similar to each certificate, also this has to be signed from the certificate authority. We have the issuer name, the date, next date, as we said, and we have a revoked certificate 1, revoked certificate 2, and so on until end. And everything is signed. Very easy. Very, very easy. Okay? So you receive this list every week, every month, every couple of days from the certificate authority. So every certificate, you have to verify it. First, from the certificate itself, the dates are okay, before date and after date is okay, extensions are fine, and then you have to look at the revocation list. Okay? Of course, again, you don't do all of this by when you click, because this will take time, but you have to do it offline. Everything here is done offline. So once you do the click, all the public keys that you have are already verifiable and you use it directly for communication. ماشي كده؟ خلاص؟ Any questions in this regard? طيب. يعني yeah, so the last thing is that طبعا the certificates extension convey additional information about the subject and issuer keys, okay, other than just the time limitation اللي هو before and after. They may contain other things. A certificate policy is a named set of rules. يبقى the extensions, they define certain rules, okay? The rules where this certificate is valid. As we said, the rules is that if I use this certificate for QU, no, I can't. I can use it only for banking services, مثلا, or for certain domains, or for certain set of IP addresses, and so on. ماشي? For example, a policy might be applicable to the authentication of electronic data exchange transactions for trading of goods. So if I want to use this certificate for مثلا trading of goods or something like this, then it's possible. But if I want to use it for any other thing, it's not possible, and so on. So these extensions have been added as part of version 3. They did not exist in version 2 and version 1, which means in version 2 and version 1, you are allowed to use the public certificate, the certificate for communicating with any server. And that was kind of, non-practical in a way. So when the internet becomes more and more complicated, you have this complicated relationship between the communicating parties, and that's what drove the motivation behind adding extensions and rules and all this revocation and all of this. So all these complications. طيب يعني احنا نقف هنا طبعا. Identity management is another topic altogether. So now we talked about key distribution using symmetric keys, Kerberos, and public keys using certificates and the X509 standards, right? So next time, inshallah, we'll talk about identity management.